So hello everyone, welcome to ML project building series again. Today we're gonna be building a submarine sonar data prediction model. From that prediction model, we're gonna predict rock, either the object is rock or it's a mine. So let's begin. So first we have the steps that we're gonna follow to build our machine learning model. First we are having the data import. We'll import the data set that we have from our sonar data, and after that we have the EDA, also known as exploratory data analysis. Here we will know more precisely about our data set. After that, feature extraction will come. All the data that we are getting from our data set is not maybe needed. We're gonna check which data is more needed for our machine learning model to learn more, and using that we will gonna select some of its features. And after that we have pre-processing. Here again, for pre-processing, it is a optional step. Like I'm gonna check if it's needed to process any data, then I'll gonna go to pre-processing. After that we have the model building process. Here as it is a categorical data set, we're gonna use the categorical machine learning models. And after that we have also have a model comparison. Here we're gonna like use all other categorical machine learning model that is used to predict the categorical data set, and using the comparison I'll gonna compare which model have the highest accuracy. So let's jump into next one. So on next one we have prediction. If we have outcome is coming as R, it means it's a rock, the object is rock. But the outcome is coming as M, it means the object is coming as mine. So later on what we have, I write here the ML model comparison. For ML model comparison, I wrote all the categorical dataset machine learning model. Here we have a logistic regression, decision tree, KN, and support vector machine. Also on the last two I wrote XGBoost and GBMS, also known as gradient boosting machines. So using all those techniques, I'm gonna compare which are getting the highest accuracy, the highest accuracy machine learning model that I'll gonna pick, and I'll gonna predict from that only. So let's jump into our Jupyter notebook. So for this model building process, we are following this step like data import, EDA, feature extraction, model building, and model comparison. So let's jump onto our Jupyter notebook. Here, what I did, I simply imported all the libraries like NumPy, Pandas, and using model selection, train test split is there as we did on our previous videos. And also for logistic regression we're gonna be used as it is a categorical data set. And also from sklearn metrics we are importing the model accuracy, like accuracy score. And after that what I did, I simply imported the data set giving the data path, and header is equal to none. The reason I did header is equal to none because if we see the data set over here, we can see like for each of the columns we have coordinates, but each of the columns there is no specified names on. So as you can see here, there is no columns over here, something is specific. It on Excel file it is showing something ABCD. And on the last we have for categorical we have raw R, and also we'll be having MMM that defines rock, R for rock, and M for mine. And all other, as you can see, all other things are coming as coordinates of the data points, and from the sonar. But we don't have any column names over here. That's why I wrote header is equal to none. So let's run over here. So let's get the first five rows of the data set. I'll simply call data.head. And as you can see, if we as we defined header is equal to none, the columns are coming as 0 1 2 3 4. And on the last, on the 60th column we are getting rock, mine, that classification. So what we can do right now, we can simply move on to our EDA process. So for EDA, what I can do here, I can check data.shape. So for here we are getting 61 columns and 208 rows over here. 61 columns showing because it is the Python always index is always start from 0 and it is ending from 60 with 60. That total counts come 61. So after that what we can also do, we can use data.describe. if I call data dot describe, there is a like count, mean, standard values, minimum 50% or maximum values. For each of the values we are getting different point data. Like as you can see, the minimum values for some of the columns are coming nearby 0.000 or 007 or 000 or double or all zero something. And for the maximum value also we are getting, all those came from sonar sensor, so that's why all those are in floating points number. From data set also we can see all those comes from floating number. So if we check the data dot d type also, we can check, or we can simply go to info. If we go to info, we can check all numbers are in points, as I told you, as all our category d type data type categorical are coming as floating type numbers. So for one is coming as object. For data types we have floating numbers and object. For object, last one is coming one, that is mine, but mine and rock indication. We can also convert this numerical form, as we have only rock and mine, so I think there is no need to convert this object into numerical. So memory usage is coming 99 kilobyte something. And as I told earlier, like 27 208 uh, rows are there over here, and 61 columns are there. So what we can do next, we can simply check how many mines is there, how many for sonar dataset on the last over here. If we go to the last column, 60th column, we can check how many rocks is being detected through the sonar sensor, and how many mines are there. So if we call data, and for data let's pick 60, and for 60 we are getting the sorry, we are getting the values dot count. Okay, something error. Okay, there is error, it will be underscore. If we're calling it, we can see 111, like 111 mines are been detected, and 97 rocks is being detected. So using this we can now what we can do now, we can separate the data on x and y. So what we're gonna do, I'm gonna take a x over here, and as you can see over here, we'll be predicting the this column like rock and mine. So what we can do here, I can drop this number of columns, 60th column, and I can take all the columns instead. So what on x, what gonna do, I'll gonna simply drop it from data. I'll gonna simply drop, use the drop function, and I'll gonna mention columns is 60, and for here axis will be 1 as it is a column. And for y, what we're gonna do, I'm gonna simply take the data the 60th column, because we are predicting that column only for machine learning model. So simply run it. So if we print it, and let me see once, sorry, capital X. So if we print it, we can see uh, up to 59th column is there, 60th column is not there. All other columns initialized into X without the 60th column. And for Y, if we check Y, only one has come, like 60th column, that is predicting a rock and mines over here. So after that, what we can do, we can use train test split the dataset, as we also done in our previous video also. So what we can do over here, already we have defined on our library to select model selection from 10 test split. So I'm gonna simply copy this one, and what I'm gonna do here, I'm gonna take x train and x test and y train and y test. So I'll take train test split function, and over here what I'll gonna do, I'll gonna feed x and y that we separated previously, and I'll gonna use test size. For test size I can use 0.1, and for stratify I can use, I'll feed y, and after that random state will come. Random state, for random state we can initialize as 1, or we can initialize as 2 also. Let me pick 1. So let's run it, and let's print x train over here. If we run x train, that simple sum randomly between some rows are initialized, not all. So let's check its shape. If we check shape from that column, 60 columns are there, it will be same, but rows has been decreased, 187 rows came. And for let's check for x test. If we check that one, only 21 rows are there, columns are same. So we're gonna train our machine learning model using train data, and we're gonna validate or test our data using the x test or y test something. So what we can do next, I can start the model building process. For here I'll be using logistic regression. So for here simply I can use model, call a model, and for here logistic regression, and for logistic I'm gonna simply call the logistic regression and use model dot fit. And for model dot fill I'm gonna simply take x train over here and y train. So if I run it, it is coming. So let's time. So as I feed it, the model is working, but we need to check using model evaluation. So simply I'm going to take model evaluation. Okay, for model evaluation what we can do, we can predict the data from the test data set like x test or y test. So I'm gonna take x train prediction, and for x test prediction I'm gonna use model dot predict, and for model dot predict I'm gonna use x train. Then I have to measure the accuracy also, so I'm gonna take ACC for accuracy, and for accuracy I'm gonna use this one, like accuracy score from scalar matrix. Now simply copy it and paste it over here, accuracy score. And what I'm gonna do here, I'm gonna feed x train prediction, and I'm gonna simply validate over y train. So let me check once. So let me print the accuracy over here. Okay, accuracy of the data set, sorry, accuracy of the model. So simply call the accuracy ACC. So if we run, we can see the 80%, 83% is coming, 83.42 percentage is coming for this prediction model. So now, which is better enough to predict something from the data set. So what we can do now, we can make a predictive system. For making a predictive system, what we can do here, we can take a input data as we did earlier on our video also, And for input data I'll convert it to numpy array. Numpy input data numpy, and I'll convert this like input data, sorry, it will be like copy it and use np.as array and paste the input data. Let me check it's it's working. And after that, what I'm gonna do, I'm gonna take prediction, and for prediction I can use model.predict, and to predict I'm gonna take input data. Okay, so we missed a line, we need to do reshape. So before reshaping it, I'm gonna use input data reshape. I'm gonna reshape it down. So what I'm gonna do here, I'm gonna use this input data numpy. It will be small letter. Okay. Let me took it and use reshape function, and from reshape I'm gonna reshape it to 1 and -1. And for that predict, what I'm gonna do, I'm gonna simply feed that input data reshape. So print the prediction, print, sorry, okay. So now what we can do, let's run it, and let's call the data again. So if we run the data, we can see it is coming over here. We can select the first one. So what I can do, normally I can open it up, and over here the first one, if we select the first one, 0.02 starting. So from here let's copy it up to here, it's coming a little bit big. Let's paste it, and from last I will remove the R. Okay, let's check it's working or not. So it is giving us R means rock. So if we check over here also on 16th column, the first row, it is the actual data is giving rock, and here also it is giving rock like R. So what we can do next, if we can do a if condition, if else condition, like if prediction, if it is prediction giving us prediction as a rock R, we can print it down like it's a, sorry, it is a rock. Or we can also define like else it is a mine. If we run it again, so yeah, it is coming like it is a rock. We do it capital letters, this one also run it. Okay, it is coming, it is a rock. So as you can see from our real data set also, it is giving us rock means R. So as of now the machine learning model is building is successful here. What we can do right now, we can go through the model comparison and test other models also. Now if we do model comparison over here, what I can do, I can simply paste this piece of code. So what I did on this code, I simply imported all the libraries that is needed for all those machine learning models, and here I called all these models. Here I wrote the names and simply calling the models. Here for logistic regression I am giving the max iteration as 1000, and for I also called decision tree, random forest, KNN, and ADA boost and others also. For here I am taking a score. For score I am iterating a for loop. For each of the for loop I am having the model dot feed, and prediction I am getting, and on the last what I am doing, I am measuring the accuracy score. After that I am plotting the comparison. For plot to plot the comparison I am getting the plot size, and I am taking the bar plot. So from the bar plot I am using some different colors like blue, green, orange, red. And after that I am plotting the x level and y level. And after that, for each of the bar I am doing a logic that the accuracy score should be visible over the height. And after that what I am doing, I am using plt show the to show the comparison. So let's run it. Okay, like x is not defined. Okay, sorry, it will be capital letter. This one will be also capital letter. Let's run it. As you can see, for logistic regression it is coming a little bit low, 79%, but the highest accuracy is giving that KNN neighbors, k nearest neighbors, that is giving 86% almost. And other we can see the second highest SBM and random forest is giving. Also grading boosting is there. The most lowest is giving us the decision tree. So as you can see from the comparison, we can tell that the KNN is working most perfectly. It is giving us the highest accuracy. So for today, this is I think enough for this model. So thank you for being for such a long time.